Welcome to our Oilfield Water Services Field Case Study series. My name is Ross McCartney, and in this series I'll be showing you field examples of how produced water analyses can be used to benefit scale, water, well and reservoir management. In this presentation you'll learn about how contaminated produced water sample compositions were used to estimate the composition of formation water being produced from a well following drilling and acid well stimulation. In this case, by knowing this composition, the asset was able to constrain the water saturation in the reservoir. Now, it was routine on Field A to undertake drill stem tests on wells after they were drilled and completed. The wells would then be acid stimulated before a further DST was undertaken to evaluate the stimulation results. Produced water samples were then collected during these DSTs where this was possible, and these samples were then analysed. The asset wanted to know what was the nature of the water being produced. Was it formation water? Was it drilling mud filtrate, completion brine or spent acid? Or was it mixtures of these? They also wanted to know the salinity of the formation water, because this would then allow them to constrain the water saturation in the reservoir. The produced water analyses were evaluated along with information on the drilling muds, completion brines and stimulation fluids. The figure on the right shows the produced water sodium and chloride analyses obtained from two of these DSTs performed on one well. The black symbols and regression line are for samples collected during the first DST performed after completion of drilling. In this case, the produced water compositions are consistent with them being mixtures of formation water, mud filtrate and completion brine. As the test progressed and the well cleaned up, the sodium and chloride concentrations of the samples decreased, reflecting the increase in the fraction of formation water in the samples. The well was then acid stimulated, and the red symbols and regression line are for samples collected during the second DST performed after this stimulation. Now the compositions of the produced water samples are consistent with them being mixtures of formation water and spent acid, although some small fraction of mud filtrate and completion brine could also be present. Again, as the test progressed and the well cleaned up, the sodium and chloride concentrations of the samples decreased as the fraction of formation water in the samples increased. Now, because the same formation water was being produced in both DSTs, but the contaminating fluids were different in each set of samples, this allowed the major ion concentrations of the formation water, that is chloride, sodium, calcium, magnesium and sulfate, to be estimated from the intercept of these two regression lines. Note that this method could be used because these ions were not significantly affected by reservoir reactions when the contaminants and the formation water mixed in the reservoir. If they had been affected by reactions, it would be necessary to use alternative methods that corrected for the effects of these reactions on the compositions of the produced water samples. From these major ion concentrations obtained, the salinity of the formation water was accurately estimated with minor uncertainty. There were several benefits of the information obtained from this work. Firstly, good estimates of formation water compositions were obtained from the contaminated produced water samples. Use of this methodology meant that it was not necessary to collect uncontaminated formation water samples during the DSTs, and so it was possible to undertake shorter tests. This resulted in significant cost savings for the asset. With the results obtained from all the wells and formations, it was possible to develop a good understanding of the compositional distribution of formation waters across the field. This showed that the shallower formation waters had low salinity and the deeper formation waters were highly saline, and these results helped the asset team refine estimates of water saturation in the reservoir. I hope this brief presentation has given you a greater insight into the value of produced water analyses. If you require further information, please visit our website at www.oilfieldwaterservices.co.uk, where you will find our extensive publication list, which cover many field cases. You can also contact me via my email on ross@oilfieldwaterservices.co.uk. Don't forget to subscribe if you want to see more videos from us on the uses of produced water and formation water analyses in the oil industry. Thank you for your attention, and I hope that we can be of service to you soon.